Hello and welcome to section 9.5, Properties of Logarithms. Now before we talk about the three properties in this section, let's review some very basic properties we've talked about already. The first one is, if I have log base b, any base of 1, it's always equal to 0. And again, that can be a useful property to look at when simplifying an expression in an equation. Another one we have is log base b of b raised to the x is always going to equal, that's right, x. And the third one is b raised to the log base b of x. That is also always equal to x. And we talked about how we can actually use these three properties to simplify expressions in the past. In the next section, you'll look at how these can sometimes help to simplify things when solving equations. Now, the last section, we actually looked at these in a slightly different way, and we looked at them in terms of natural logarithms, and they really are, in fact, the exact same properties, but they're going to look different because we use the notation for natural logarithms. So the first one actually ends up becoming the natural log of 1 equals 0. Again, natural log replacing log base b because we're looking at log base e in this case. The second one becomes natural log of e to the x, and that's equal to x. And the third one becomes e to the natural log of x, and that also, again, equals x. So these are a few of the basic properties that we've talked about already. Now we're going to extend them to some other properties. And the first one I'd like to talk about is the product property of logarithms. Now, the product property of logarithm tells us that if x, y, and b are, again, positive real numbers, and notice we're still working in the real number system here, and b does not equal 1, again, that's a straight line, then the following is going to be true. Log base b of x times y is equal to log base b of x plus log base b of y. So if you look carefully at what's happening here, we have two values that are being multiplied together, then being separated and added together as logarithms. So now remember that these represent exponents, and so we have multiplication here, and then we end up adding those exponents together. Where have we seen that before? Well, that actually happens in one of our rules of exponents. If we multiply bases together, then we can add the exponents together if the base is the same. So that's what this property is based off of, and we can actually show how that is true with a little proof. Now, you may not have seen a lot of proofs in the past, but I want to take you through one here with just this particular property. So let's start by letting log base b of x equal m, and we're going to let log base b of y equal n. So we're going to start with that assumption there. Now, if we apply our definition of log to this first one, we would get b to the m is equal to x. And with this one, we would end up having b to the n is equal to y. So all I'm doing there is applying the definition of log to both of those expressions. Now, if these two statements are true, then I could take the two left sides of the equation and multiply them together, b to the m times b to the n, and that should equal the two right sides of the equation. Again, if these are equal statements, then it goes to say that this should also be a true statement. Now, once I have it in this form, notice that I have the same base here on the left-hand side, so I can rewrite this side as b to the m plus n is equal to x times y. And now I will take this expression and I'm going to rewrite it using the definition of log. So I'm going to apply the definition of log to this statement. So if I do that, I'm going to get log base b, there's my base, of x times y is equal to m plus n, which is the exponent. And to finish the proof, all I need to do now is remember that originally I said that m was log base b of x and n was log base b of y. So now I bring this down and substitute it in here, and so I end up with log base b of x times y is equal to log base b of x plus log base b of y. And this is the end of the proof for that particular property. So again, notice how we did use our rules for exponents here to simplify in that step right there. All right, so now let's go ahead and apply this in a couple of examples. Now that we see where it comes from, let's try to apply this property to a couple of different problems. So the first example I'd like to look at and try to simplify is log base 3 of 5 plus log base 3 of 8. In this particular case, I'm actually going to take the property and I'm going to use it to what we call condense this particular log. In other words, I want to rewrite this as a single log. So to do that, I would end up having log base 3, and again, I take these two arguments, I multiply them together. So it's 5 times 8, which becomes log base 3 of 40. And so I can simplify it into a single logarithm. Let's try another one. Log base 4 of y cubed plus log base 4 of y minus 9. Now again, I see the addition here. I've got these two particular arguments, and so to combine it into a single log, I multiply. So this becomes log base 4 of y cubed times y minus 9. And if I wanted to simplify that a little bit further, I could, and I could say this is log base 4 of y to the 4th minus 9y cubed. Sometimes it's helpful to rewrite it this way. Sometimes leaving it in its factored form will work. So it'll depend on what kind of an equation you're looking at as to which form you would want the argument to be in. All right, so in these two particular cases, we're doing something that we call condensing the expression. In other words, we're taking a larger expression and we're writing it into a smaller one. And this will be one of the most common uses of the product property. All right, let's take a look at our second property. And for that one, it's going to look a little bit similar to the one we just did, but it has a slightly different operation in it. So for this one, we have the quotient property of logarithms. And so notice the definition looks very similar to what we just had. If x, y, and b are positive real numbers again, and b doesn't equal 1, then log base b of x divided by y is equal to log base b of x minus log base b of y. Now again, where have we seen division and subtraction in the same statement? And again, you should be thinking about one of our rules of exponents. Now, I'm not going to go through and prove this particular one, but let's do a couple of examples, again, of condensing and using this particular property to simplify expressions. So let's try just a pretty standard one here. Log base 3 of 13 minus log base 3 of 2. Well, this one doesn't give us too much exciting information, but we can use this to actually get log base 3 of 13 divided by 2. So again, I'm using the property in reverse here in that I've got the subtraction, I'm combining it into a single log. I always like to use parentheses to make it clear that I'm taking the log of that particular expression. All right, so that one didn't do a whole lot for us. Let's look at another one. Suppose we have log base 5 of x minus log base 5 of y plus 1. Well, again, even though there are variables in these two expressions, we can apply the quotient property. So we get log base 5 of x divided by y plus 1. And again, it's pretty clear that I'm taking the log of this expression, but I'm going to highlight that with some parentheses. And we could keep going with examples like this. Now, sometimes you'll be able to simplify the argument you come up with. Other times you may not. The important thing is to be able to rewrite it as a single log. All right, let's look at the final property for this section, and this is the power property of logarithms. And it actually wrote out very small here, so I'm going to rewrite it for you. This is actually log base b of x to the r is equal to r log base b of x. So this particular property is actually one of my favorites. I like to use this quite a bit when I'm solving equations, and it again allows me to often get a variable out of the exponent when the exponent is part of a logarithmic expression. So let's take a look at a couple of examples of how this one might work. But before we do that, I want to kind of go back and look at how this relates back to the product property. So if, for example, I wanted to look at log base 2 of 5 cubed, I could rewrite this a couple of different ways. Now, 5 cubed means I have 3 of those. So that's actually log base 2 of 5 times 5 times 5. And if I look at that, I could actually apply the product property here and rewrite this as log base 2 of 5 plus log base 2 of 5 plus log base 2 of 5. Again, 3 5s are being multiplied together, so I can expand this out into 3 separate logarithms. Well, these 3 terms are all the same. I have 3 log base 2 of 5, so we know that with repeated addition, we can write that as multiplication. So this becomes 3 log base 2 of 5. And so notice by using the product property, I was able to rewrite log base 2 of 5 cubed as 3 log base 2 of 5. And so there's a way we can use one of the properties to show that this property will in fact always work. Now let's apply that to a couple of different examples that we might have. So let's start with log base 2 of x cubed. Well, here we have a variable in the base, but again, it'd be nice to get rid of that exponent there, so we apply the power property and we say that we can rewrite this as 3 log base 2 of x. And now that may help us to more readily solve an equation down the road. Here's another one. Log base 9 of 5 to the negative third. Well, it's just a negative exponent. I can bring that to the front as well. So this one would be rewritten using the power property as negative 3 log base 9 of 5. Or let's try one more. This one can sometimes be a little bit tricky, but it's actually one that allows you to apply the power property. And that's log base 4 of the square root of x. Now remember that the square root can be rewritten as log base 4 of x to the 1/2. So you would actually, with this kind of a problem, want to be able to use the fractional exponent representation of the square root. Now we can apply the power property, which would allow me to write this as 1/2 log base 4 of x. So those are the 3 properties that are introduced in this particular section. And you'll have an opportunity to practice each one, and then you'll be putting all 3 of them together and using them to either condense or expand. And we'll talk about that in the next video.